This is sample problem 5.6. It says in here that we have a famous Amos bite-sized chocolate chip cookie weighing 7.25 grams, and it's burned in a bomb calorimeter to determine its energy content. The heat capacity of the calorimeter is 39.97 kilojoules per degree C. During the combustion, the temperature of the water in the calorimeter increases by 3.90 degrees Celsius. Calculate the energy content in kilojoules per gram of the cookie. So the idea here is essentially that you take some piece of that cookie and you put it in a bomb calorimeter and you measure how much heat is released when you combust it, right? Remember, combustion is an exothermic process. It releases energy. Okay, so let's figure out the heat content. So Q. Now notice they give us the heat capacity of the calorimeter. They don't give us the specific heat and the mass of water. They give us the heat capacity of the calorimeter. So that means that the heat that is absorbed by the calorimeter from the combustion of the cookie is equal to the heat capacity times the change in temperature. So they give us some values here. They tell us the change in temperature is 3.90 degrees C, and they give us the heat capacity, 39.97 kilojoules per degree C. And our change in temperature is 3.90 degrees C, right? So that tells us how many kilojoules of heat was absorbed by the calorimeter. So 39.97 times 3.90, and you get 155.9 kilojoules, okay? Now, they want us to calculate the energy content in kilojoules per gram. Well, they tell us the mass of the cookie. The mass is 7.25 grams. So all we have to do is divide the energy that's released by combusting the cookie by the mass of the cookie, and that will give us the energy content per gram. So Q equals, let's put it over here. Let me write it over there. Q over M. Let's erase that. Make that a little bit better. Q over M equals the energy content per gram of cookie. So this is the energy content, but not per gram. Okay? Be sort of like this. Suppose I said, how many pizzas were eaten by the class today? Oh, 30 pizzas got eaten. Okay, well, there's 30 people in there. How many pizzas were eaten per person? You would divide it by 30 people. Same thing here. The amount of energy that's released is this, but the cookie weighs 7.25 grams, so we're going to divide it by that mass. So 155.9 kilojoules, and we're going to divide that by 7.25 grams. And you get 21.5 kilojoules per gram. Now, let me make a, actually, you know what's interesting about that? Let me show you just a quick little calculation here. There are 4.184 kilojoules is a kilocalorie. So even though this question doesn't ask for it, just to show you, you could do a conversion and figure out how many calories per gram this has. So you'd say, okay, we have 21.5 kilojoules per gram, and then 1 kilocalorie per 4.184 kilojoules. That's the conversion factor. So if you divide that by 4.184, you get, 21.5 divided by 4.184 is around 5.14 kilojoules. So that's kilocalories per gram. And if you think about it, that could be possible. It makes sense because carbohydrates and proteins are 4 kilocalories per gram, and fats are 9 kilocalories per gram. So this is between 4 and 9, right? And it's a little closer to 4 than it is to 9, which tells me there's more carbohydrates in this cookie than there is fat. So it's probably a pretty high sugar and probably a high refined flour content in this cookie. I'm not sure if that was the original formula for Famous Amos cookies, but that might be what it is right now. I did want to make one quick comment about the sign. So when people use the term energy content, they usually mean that you're going to have a positive value. But I do want to point out that when this cookie is burned, the energy, the heat, Q, is going from the combustion, from the burning of the cookie, out to the water in the calorimeter. Okay? So that means the cookie is losing energy as you combust it. It's going out to heat up the water. So the delta H of reaction would be negative heat of the calorimeter. So the calorimeter is absorbing heat, so you get a positive value, which is what we got in our result. But we should point out the heat of reaction is actually negative, right? The negative of a positive is negative. So this is a negative reaction because it's a combustion. Combustion, delta H is negative.